Okay, my name is Doug Newman. I'm from NASA ESDIS. My colleagues Ryan Abbott and Deep Mystery are also part of the EED contract associated with ESDIS. Um, this is the machine learning and the art of data discovery session. With the advent and popularity of ChatGPT and other chatbot technologies, we see an opportunity to improve the quality of search and discovery within Earth Science Data Archives. Multiple machine learning technologies that can be brought to bear on the problem of producing high quality results from Earth science queries, chatbots, knowledge graphs, large language models, vector embeddings, etc. And these technologies could be applied to both the search of Earth science archives, where the user has an idea of what they're searching for, and the discovery of data, where they don't. So we put out a call to our various agency partners and industry and friends at ESIP to join with us and discuss this topic. Unfortunately, as you're probably aware, many of our agencies and agency and partners were not able to participate in ESIP this summer. I myself am only able to participate remotely. Same with Deep. So we are only presenting work from the ESDIS project and what we are doing in the area of AI and ML for data discovery. So we're going to have three parts. The first and last part are going to be taken by Ryan Abbott, and sandwiched in the middle will be Deep. So without further ado, I present to you Ryan Abbott.
Thank you, sir. Everybody can hear me in the room? Give me a thumbs up on the back. Well, wonderful. Share over here real quick. Bam. Bam. Alrighty. All right, yeah, like Doug said, my name is Ryan Abbott. I've been part of this particular ESDIS contract for about 10 years. We've been working on some AI ML stuff for the last couple. Today, we'll be talking about the art of data discovery and how machine learning can assist with that. And so the way we want to approach this today is in three parts. I want to go over the early days of discovery. So I was part of the Earth Data Search team 9-10 years ago when I started here. And then Deep's going to go through how discovery works today, not necessarily in our platforms, some of it will be, but also just at a higher level, what is capable. And then we're going to close out with a discussion around the user experience associated with this. And this last section is really going to be more of a discussion and a call for some feedback and input, more so than us telling anybody what to do or what we are going to do. So to get started, the early days of discovery, at least from the NASA ESDIS perspective, was the use of the Common Metadata Repository. So as it stands today, we hold just over 1.8 billion records. You've heard this numerous times over the years, especially at ESIP this week. This serves over 100 million queries every month, between 100 and 150 queries. And it describes and links to, as Doug alluded to, or actually mentioned the other day, hundreds of petabytes of science data. In order to ensure the discoverability of all of our data, the API that is associated with CMR, the Common Metadata Repository, has a large feature set. The tools that help us most directly with discoverability are the ability to sort, filter, and then offer full text searching across that entire metadata repository. It offers relevancy, so an internal but static index based on elastic search capabilities. This isn't some ever-evolving thing. This is industry standard specification-based elastic indexes. We also offer the ability to sort on usage. So this is an internal metric system that at build time and deployment of CMR is synced, and the usage numbers for all of our data is then injected into the data for the use of sorting those results when they come back to you. We offer facets across collections and granules in CMR. So this is really great for filtering things like science keywords or maybe the platform, the instrument that it came on. This is obviously a feasible thing through the API, but is really assistive to front ends. And then free text search. So this is something that is heavily used within any API, but specifically with CMR because it's a very text-heavy data sets or collection of data sets. And so we want to make sure that our descriptions and the names of our data are what is going to ensure that the correct data comes back for a particular user search. One big thing that it's lacking is feedback. We collect manual feedback today via tickets, forums, one-on-ones or conference feedback. But there's really no way for us to adjust what comes back without getting manual feedback and then go manually entering conditionals into the code that will accommodate or changing indexes. We had a large discussion about this on a different ESIP presentation around how AI is potentially changing that. But today we have no real ability to do this on the fly or automatically. So let's take a closer look at how Earth Data Search utilizes those features in CMR. And those features are what we're seeing implemented in Stack and in many geospatial APIs, which is the faceting, but largely geo and spatial and temporal. And so we take a look at this large UI, and we're going to zoom in specifically to our capabilities for search on the left-hand side, and then of course the results here. So you can see facets and you can see our search. So typing to search for data, temporal, and then spatial. I want to focus today on just that upper left-hand corner. First, I have to move this thing out of my way so I can read my text. So you can see we have free text search. This does offer an autocomplete capability, so that will allow you to see the faceting information on the left side, but also a couple of more features in there. But you can also just type in whatever you want to here and press search. You also see a temporal search, which is a date picker, and then a spatial search, which offers essentially the tools we're all used to, drawing polygons, circles, dots, whatever, but also the ability to upload shapefiles. So when you look at that and you start to think to yourself, like, what are ways that people want to be able to use those three things? Because from a user experience perspective, and we had this discussion 6-7 years ago, date pickers are kind of annoying. Drawing polygons are really kind of annoying. So what can I do to prevent the unnecessary clicks that I have to do in that overhead to accomplish a search? And natural language processing was the solution that we came to. So we can take an example of something like soil moisture over Paris in February of 2012. If we look at this and we try to break up into pieces, and at the time in Earth Data Search, we're using a tool called Core NLP. This is a Java library from Stanford, and it still exists today, actually. They've continued to make improvements to it, but its core functionality is to break up sentence structures, not to necessarily do additional analysis of what those things are, but to break up the pieces of text to understand temporal, potentially spatial, and different pieces of language. So if we look at this one, we can see that Paris is clearly our spatial region. And in our implementation, Paris would be pulled out using that core NLP and then sent to a geocoder. No different than Google, essentially, back in the day, where it would return its best known polygon, but it's of course a search. So we just took the first one, and sometimes it was the same, sometimes it wasn't, sometimes it was a point, sometimes it was a polygon. Next, we can look at the temporal aspect of things. February of 2012. And so this one is a little bit more dicey. So, we're talking, again, 7 years ago. The functionality here was really, here's a date, and we can have a large set of conditionals that can accomplish translating this from a piece of text into a date. Obviously, sometimes that's easier if it's just a year, but February of 2012, we have to construct a date, the first of the year, or the first of the month, rather. And then lastly, what is the actual search term and the data that someone's looking for? So in this case, we're going to use soil moisture. So that gets sent to CMR. So now we have a spatial value, which is coming back from a geocoder. So we have a polygon or a point that we're going to send it to the CMR API. We have a date, which is the temporal value, which you saw in the interface, and then the soil moisture. So now we have 3 pieces of information that can easily be broken out into that interface and then sent over to CMR as a single request. So this saved the user a ton of time. They didn't have to use those interfaces anymore, and they could use natural language processing. Wonderful, right? Not so fast. You met Paris, Texas, right? Probably not. It was pretty common, though, that every time you would search for something, you would get a different place. And this isn't the fault of Core NLP or of Google. It has no context to understand what you're asking for. The temporal considerations were very difficult because when we had that February of 2012, not only is 2012 a leap year, our search is also in February, so we now have to accommodate the fact that there's more days in that month. And so if we're using that month, now our time range, our temporal range is different. Then of course, free text is great, but soil moisture could be a vast, like there's so many different collections that we could be searching for. And so it didn't really narrow it down very much. It did a good search. It saved the user some time in that aspect of things, but it was common for the user to still have to use the drop downs to correct the spatial and to correct the temporal. And so this was arguably worse. When it was incorrect, the users actually had to do more work because they did the least amount of work and then had to do the other portion as well. And so fixing all the issues associated with this just became a game of whack-a-mole. We're always going and adding new conditionals. We're adding, new ways for the spatial to be correct, trying to adjust it, but it just never worked out. Additionally, it was decoupled. So the Earth Data Search team was responsible for maintaining all this code, and no one else was able to contribute to it. No one else was able to even utilize it. It wasn't a core piece of the CMR. It was in Earth Data Search. So other clients that use CMR didn't really have a means of doing so. And then the feedback all went to the Earth Data Search team, which in all reality, oftentimes, if we're talking about relevancy or usage in those strings, it should be going to the CMR team. So not great from a feedback perspective. So we rewrote Earth Data Search about 4 or 5 years ago, and the decision was made to not re-implement it, and instead to consider re-implementing it when technology or when we had a better grasp of what and how it could be powered by was available, and we would implement it at that time. So now I will toss over to Deep to go through exactly how search and discovery of Earth science data with AI and ML helps us re-implement this.
Yes, let me go ahead and share my screen. Okay, can everyone see the slides? Yes, okay, cool. Hello, everyone. My name is Deep, and I'm a software engineer at Raytheon working on NASA's CMR team. So yes, I'll be talking about exactly what Ryan just mentioned of how, with the rise of artificial intelligence and machine learning, especially natural language processing, how we can change the way that we were searching for data using NLP in the past, and now how we can use this term like semantic search to discover NASA's Earth science data more effectively. So how can we do that? In the recent times, there's a new technology called vector embeddings. So what are vector embeddings? Well, they're essentially a way of converting text, whether it's word, phrase, or entire document, into a series of numbers. These numbers are these numbers form a multi-dimensional vectors, and similar meanings are placed close together in space. So if we were to take an example, the phrase sea surface temperature ends up near ocean heat because the model has learned from a large, massive text corpus that these two terms often appear similar in context. And then on the other hand, something like air pollution would be placed much further away since they're topically different. So this is what enables the semantic search. Now we don't need to know the exact right word. The system is able to understand the intent and find the collection based on its meaning and not just exact text matching. Okay, how can we leverage this in an application like Earth Data Search? Well, what we've done is we've enabled an embedding-based search system where we have taken fields from UMMC, like the title, abstract, and science keywords. These are all embedded into the vector space ahead of time in a vector database, so the system can compare and find data sets quickly. So say a user comes in and enters a free text query like snowfall over Alaska in winter. We embed this as well using the same text embedding model. And then the phrases like snowfall might not be in the data set, but the model is still able to retrieve other collections that talk about precipitation or snow depths that are conceptually still related. And this gives users the freedom to search in plain English and still get highly relevant results. This also enables users to discover data that might not be realized that they're relevant. But of course, the discovery isn't always about what to find, but we've also added a spatial and temporal constraint. So say a user types something like rainfall over Gulf of Mexico last spring. We're looking for keywords. So first, what we're going to do is we're going to find the spatial, which is going to be Gulf of Mexico. And then here we're using a natural language geocoder to translate that into a bounding box. And then this is going to be applied as a spatial filter in our search. Then we interpret last spring as a temporal range. So for this, it will be March through May of 2024, and then apply that as a time constraint. Then we combine all of this with the semantic embedding, and then the core concept here would be rainfall to retrieve the relevant data across all space, time, and meaning. So again, this is a huge step forward from earlier system that Ryan just talked about. Here, we are still treating these as an isolated system, but now we can use the power of LLMs to parse out these different parts and then call CMR API in that way, and we don't have to do that manually. So now that we've seen how this works conceptually, let's see how it will work in action. So what you're seeing here, hopefully you can see a NASA logo and a Chainlit application. Cool. So here we have we've integrated our embedding search using a Chainlit UI. So here I can come in and I can do a search. So say I want to know about wildfire smoke plumes over California. So what we're doing here is we're using an LLM to parse out this query. So we know that, okay, we're interested in wildfire smoke plumes over California, and we know California is going to be your spatial, and this is going to be our keyword search, essentially. So the LLM is able to figure out, okay, the specific location, it's going to be California, the Earth Science search term is going to be wildfire. And here it's calling the natural language geocoder, and then it's converting the text California into a bounding box. And as we can see here, it was able to successfully draw out the polygon for California. And now it's doing another step of thinking process where, okay, so the user is still interested in the California and the smoke plumes, but now I have the location and I still need to go find the wildfire data for that. So it's going to call CMR natural language search for the specific query. And since we did not provide a temporal value, it's not going to include that. So it's not going to include the start and end date. And here, as you can see, it called CMR successfully, and it returns collections that it thinks are relevant. So as we can see, the top two are about FireX AQ, and let's see. So even though these data sets are not talking about smoke plumes over California, they're talking about wild emission and airborne measurements conducted in California. It's still able to realize that, okay, this is, even though it doesn't have the same exact word, but this is still going to be related, and that's why it's showing these as a result. We can do another search like vegetation loss in Amazon rainforest. this will do the same process. We'll go through the thinking process and then figures out, okay, it's Amazon rainforest and they're interested in vegetation loss. And same thing, we're going to do the natural language geocoder query. For some reason, it's only, I actually noticed this today, it's only mapping out this, whereas it should be the whole thing. I'm not sure why it's doing a small region, but something definitely to look into. And yes, so we got successful call from CMR, and now it's just formatting the results. So here again, even though the word vegetation is not in the abstract of this, but it's still treating this as a number one pick because it's talking about concepts like plant psychology, micrometers, and carbon cycle, which are all related to deforestation. So we've talked about how the users can ask questions more naturally, but what happens after that? How do we keep improving the quality of the results without having to rewrite code? Well, that's where learning from feedback comes into play. So what we've done is we've started adding feedback tools like thumbs up and thumbs down into our Chainlit applications, where the users can tell us if the data set was relevant or if it wasn't to their original query. And then the way this works is behind the scenes, we use the feedback as a form of triplet, where it's going to be the anchor, the positive, and the negative queries, and then we apply that to a training model called triplet loss, which teaches the model to pull positive pairs closer in the vector space and then push the negative ones further away. And then the idea is over time, this will reshape the whole vector space. So similar searches are surface more to the top, and the negative ones are pushed away. But another challenge that we've been dealing with is if the system is learning from user, how can we automatically check, okay, that the responses are getting better and they're not getting worse? Well, that's where evaluation comes in. And what we've done is we have created an evaluation set from using GCMD science keyword and their description. And then we are using an approach called using LLM as a judge to assess how relevant each collection and queries are. And then over time, when we retrain the model, we can go back to this ground truth set and see, okay, like, are we performing better or are we going down in our performance? So yes, this is what we have so far for a natural language search powered by embeddings. Our goal is simple: to make it easier for users to use our application and find data without needing to have metadata expertise in it. With that, I'll kick it back to Ryan, and I think he's going to talk about UI UX changes.
Awesome. Thank you, sir.
I think I stopped sharing.
This portion of the talk, like I mentioned, is going to be more of a call to attendees and a lead kind of discussion. These slides were actually generated by our UI UX lead, Trevor Lang. I'm going to do my best to translate, so please excuse any hiccups, but here we go. So user experience associated with this. And so, we have an old experience and we've outlined the reasons why it's not great and its hiccups. And while the technology that Deep just went over is very promising, what we don't want to do is just go slap all that functionality into interfaces like Earth Data Search and just hope that it was better. The goal here is to make contact with as many people as possible before throwing something like this in to ensure that the user experience is actually better. So we have this analogy here where you walk into an art museum, right? And it's just lined with hundreds and hundreds of feet or hundreds of individual amazing photography, paintings, and photographs. And you think to yourself, like, man, I know nothing about this information. I wish I had some ability to kind of maybe group these things together and I can learn about what I'm looking at a little bit better. And the reason we use this analogy is that CMR and what NASA has within its holdings is an incredibly vast amount of information that is very powerful. However, unless we can search it and discover it and do so in a very user-friendly way, storing that information isn't super helpful. And by creating interfaces that are frustrating, we deter people from using the data and understanding what exactly we hold. And so, how is the data being discovered today? And this is the current versions of Earth Data Search that I discussed a few minutes ago. It's search interfaces, right? You're used to clicking on facets. You're used to clicking on date pickers. We have catalogs of information, just lists and lists of things. And then, of course, we can always just ask people, or in this case, ChatGPT. Who are the people that want to discover the data? And I think this is one of the bigger problems that applications like Earth Data Search face, is that the number of people and just the breadth of their experience and expectations is very large. So we have, analysts looking for analytics across our platforms. We have researchers looking for scientific data. We have students looking to accomplish papers and basic research. And of course, we have the public. This is anything from teachers to news publications. You see lots of really pretty pictures come across different news outlets over the course of the winter. And obviously with natural disasters, we see the need for our information to be readily available and consumable for public consumption. Where do the users that are searching for this information struggle? And again, because of the large spectrum of people and needs that use our data, the struggle points are also very vast. And so across different verticals or fields of science, we have differing vocabularies. The data doesn't always exist exactly with NASA in our holdings. And it's something we've talked about a lot. Like, how can we potentially converge on the data sources? Can we put them all in one place or make a tool that is capable of finding them so the users don't have to? Of course, the data can be very complex. And what's interesting there is a data point or a data file underneath one of these collections that is in CMR, or a granule rather, could be a text file, could be a PDF, could be a netcdf file, could be some kind of cog. And then of course, relevancy, like what is relevant to the search that I'm giving? If I can only give you 2 or 3 words, or if that's all I'm offering you in a search interface like Earth Data Search, for instance, how can I be sure that the information coming back is relevant to the user? It's very challenging. And then on the other side, we have the scale issue, right? So files are very, very large. Downloading gigabyte files, not really feasible for many people, or terabyte files even. The collections can be very large. So the collections themselves could have hundreds of millions of granules in them. And so how do we find the ones that someone would be looking for? Even if they've given us a spatial and a temporal constraint, there could still be tens of thousands of granules within that collection. We have a little over 12,000 collections right now in CMR, and that's just our holdings. Again, if we're thinking about other verticals or fields of science and other things that we haven't considered, there's a lot of collections. And then, of course, versions. This is something that I think every scientist struggles with a little bit, especially in the form of citing papers and stuff. Data can change slightly. And over time, we have different versions. And so how do we keep track of those things? And how do we ensure that the most relevant versions, in the event that they're not just new, they're slightly varied versions that both still provide value? How do we ensure that the right one is found? At the end of the day, all users of systems like this just want help answering complex questions with data. And so how are we applying AI ML to search and discovery? A lot of what what Deep just went through, natural language search is definitely one of those. Entity recognition is going to be very useful in this field. Semantic search using embeddings, which of course is supportive of those two things. Relevancy ranking is is going to be very important, right? So this is allowing us to use more context and more math to determine relevancy versus using fine-tuned indexing, essentially. And then recommendation engines kind of fall in the same place here. And going back to the conversation that I was having on Tuesday, where today search and discovery is really about fine-tuning indexes, right? So we've had discussions in the past, like we have NISAR launching very soon for NASA, right? And when that data comes out, we want to make sure that users are finding that data. The assumption is that that's the information they would be looking for versus something else that may match a search term, but is an older piece of information. And while that seems like something would make sense, that's not always the case. And so instead of introducing this human element where we're fine-tuning the code using conditionals or changing indexes, we're using AI/ML, which is a more math-based approach using, again, what Deep had mentioned, cosine similarity, and now synonyms are taken into account, and we can start to introduce more context into these searches to make sure that they're good. Well, the results are better anyway. And so how might using those things improve the discovery of data? Well, ultimately, it's possible that we can introduce less friction. And so that NLP approach that you saw in Earth Data Search that is active today could get better and prevent users from having to adjust those interfaces. The results themselves will have potentially more context. What is it that we can provide in those search results or in those search queries to our backend systems to improve the results and by providing them more context? And are there ways that we can, similar to the interactions you have today with ChatGPT or Claude, whichever AI tool is your choice, it's knowledgeable, it has a history of your search results, it tries to understand your science. And then unexpected discoveries. I think that one of the things that there are many people have been chasing, and I think it's probably people more like me who are more, software developers or computer scientists versus actual, earth scientists, is really how can we start to pull out things that no one saw before? Because there's so much data that we don't really have a good way when you run a search to just search all the data available. But ultimately, if we're talking about matrix math, that may and should become much more feasible to start helping scientists discover things that previously didn't appear to be correlated, but all of a sudden, with new technology, we can show those correlations. So what are the risks though, right? Because we could introduce all these things, and like I said, we could slap in our interfaces and just kind of make a whole bunch of assumptions and go to town. But there are some risks here. A lack of trust and loss of control. So again, when we go back to the slide about who the users are looking for these things, I think that there's a technical difference, in spectrum that our users lie on. There's a expertise from just the field of science they're looking into, and there's a privacy concern. And so they want transparency. They want to be able to explain and understand the systems. They potentially don't want this black box. If you give me results, I need to know where it came from. And again, that's probably more from the scientist perspective. When I have to write a paper, I have to be able to document where my information just came from. And this is something, Jed mentioned this morning in the plenary. Trust in our data is super important. And while we could choose to not prove things out and provide the information that will ensure that people trust the data, it's in our best interest to do so. Bias is another. So this can be introduced into a system through training. And so as Deep mentioned, we are using triplet loss. And so while that's fantastic, we also have to be sure that our systems are not taking feedback repeatedly and eventually adjusting these large models to being more sufficient for a particular field of science or a particular user that was on our previous slide. And then, these systems are augmented by user feedback. That's ultimately going to limit data even for that user, right? So now think about your Instagram feeds or your Facebook feeds or your YouTube algorithms, right? We all know the algorithm exists. And this is how it happens. When you start to give feedback, even if we were to tailor these results to an individual, now you're potentially seeing results that are only in your kind of your bubble, right? And that's not to say that it's bad. That might be good. But us as not trained scientists don't want to be making those assumptions. And these are things that we want to be able to talk to scientists in the field to understand better. And so this is a couple slides here on just kind of this tension, right? So given that spectrum of users, we have two ends of this particular spectrum, and it's control and automation. And this is on the left side, we have control. This is, I can control every single thing. This is like the facets. This is the date picker. I want to be able to adjust it by the minute because my data that I'm looking for is actually real-time data, and I need to know within, the minute, the hour, instead of just the month or the week. But plenty of people, if I'm looking maybe at the more of the public consumption and like, I just need a pretty picture to throw on my newscast or my blog post or something for school, the automation is super important. But what's interesting about the automation is that even advanced scientists, there are plenty of things that we can do to help remove tedious steps in science, right? So one of our goals on the Earth Data Search team for years has been reducing the number of steps to science. This doesn't directly correlate to clicks within an interface. It does, however, mean if I got your information to you, but you still have to take that information, that file you were provided, and then go do 16 different things through Panoply or some other Python scripts that we could easily have done before the file got to you. That's a reduction in steps to science. And that ultimately means there's more science being done in a shorter period of time. And then we have this ease of use and granularity. And this is kind of the same thing, right? Where you would typically think that something that's more automated is easier to use, but the granularity in which I can get to is not. And so it's just kind of a different synonym for describing essentially the same problem that we are trying to ensure we don't just take a guess and go forth with. And I think one thing in here where there's this idea that, right, let's go here. So how do things work today? This is kind of just to describe, again, that steps to science, right? So this is not something you're going to see in the interface. I'm not expecting anybody to read this. It's really just a visual of the steps that would currently take to accomplish answering a simple question to something like Earth Data Search. And you can see there's lots of things here. And of course, some of these could be skipped. Some of them might be actually more elaborate, but this is 12 steps to essentially get to a data point in a data file. And in our best guesses, if we're making assumptions, we can get to a place like this where we're actually more efficient, if you will, and can get you the information that a scientist needs much, much quicker. But everything from 2 until 6 is a user experience, we'll call it issue, that we are concerned with and don't want to make assumptions with. So if we look at what Deep has presented and the challenges that I've discussed, where could we be going, and where is it that the science community thinks that we should be going? And so this is where, I'm kind of calling out to as many people as possible, this afternoon or, throughout the rest of the week and on. I'll make our email addresses readily available for discussion. But where we are today is this keyword search. It's spatial, temporal, and research-focused filters. And of course, this is all just metadata driven. And so you're in a world where, like, if you want your data to be found, because you're a data scientist and you want your information to be utilized, you have to kind of cheat the system in a world where Google is, rather like Google today, where you can change certain terminology to make it better. You can utilize the GCMD keyword pickers to supply better keywords. But ultimately, that's just a manual process and it isn't sustainable. So in the near future, our assumptions and the things we want to talk about is conversational discovery. So you're seeing a lot of interfaces jump over to chat-based interfaces. And what does that mean for interfaces like Earth Data Search that are historically very, click heavy and granular functionality has been kind of the desire and the built-in feature set? Is that something that needs to persist? And then additionally, one of the things that Doug has been working on quite a bit, with me and the search and discovery teams, is this idea of quality of our metadata. And can and should we be using AI assistants to not only improve the quality, but enrich our metadata so that when we're utilizing it in the systems that Deep has discussed, we are confident that the decisions that are being made correctly because the information within those metadata records is correct. And then do we need the ability and can we offer this kind of contextually aware natural language explanation of what's happening? Because sure, we can return the information to you, and that's all wonderful. But if we're returning the information to you and you don't know where it came from and you're not confident, what information do we need to provide to instill that confidence level and that trust in the process to all the users? And then lastly, oops, go back. Sorry, I'm trying to move my little video thing out of the way. And then, up next is kind of the future that we're not quite at, but there's a few people working on. And this is this intent-aware agents and AI ML generated analysis. So this is where we start to introduce an LLM that's capable of coding. And when you ask a question, the response comes back to you. You never had to put it into a Python script. And so I think that the information of the kind of the challenges you see in the near future column are now just exacerbated, right? There's more, but different information that we need to be providing to users on those results because it's actually doing some level of work and we have to be able to trace that information. That sounds great. But how do we collectively, not me individually, not Deep or anybody individually, collectively, how do we get there? This is where everybody here in the audience comes into play. We want to make sure, again, that we are building the right interfaces. So how do we evaluate relevance across various types of geospatial data? If I'm searching in Earth Data Search, how do I ensure that you are looking for this particular field of science, right? Is this a sea surface temperature thing, or is it more of like a geology thing? So maybe soil moisture versus geology. How much automation is too much? And when do the users of these applications start to fear there's a loss of control? We don't want that to be the case. Right? It's the opposite end of the spectrum of having to click every little box and know where all those boxes are and these cluttered interfaces. Do we only need chat tools in there, or is there a place for these kind of traditional discovery interfaces? We've talked a lot about the idea of using a chat interface, but being able to additionally filter the results that come back using maybe you have some facets, right? So rather than relying on the LLM or the back end to make these assumptions about your field of science, for instance, you can use the facets. And or is that something that we want to do more at a profile or a user perspective instead of every time I search, I have to go click the same box? And then what does the ideal experience look like, right? So that's the large question here is like, how do we want to be interacting with these things? But again, as a whole. And so this is why it's important that we try to talk to as many different users from those larger categories that we discussed earlier to ensure that the interfaces that we're able to drum up from this are effective for as many people as possible, even though ultimately the main goal and as this is a driver here is like doing research and making sure the information that we as taxpayers fund and as ESDIS is responsible for holding is in the hands of the right people doing science that is impactful. and how do we prevent these filter bubbles? So if we're offering just like Deep mentioned, the thumbs up and the thumbs down, that's great. But like, what other ways can we get feedback from users in a real-time way? If you can't see me, air quotes, like real-time way where it's in the interface. It's not requiring you to open up an email and shoot off information to us that we're going to have to organize somehow on the other end. Because we want to ideally automate as much of this data collection as humanly possible so that we can be adjusting our models and our searching and discovering automatically. So, and then if you had essentially a magic wand to improve the way that you discover data today, what would you make happen? And what concerns do you have in bringing these approaches of AI and ML into science? We've obviously discussed kind of transparency and understanding where things come from, but is there other concerns that we maybe haven't thought of? And then what should these systems understand about our current needs and usage, right? Because there's a lot of information. I think this is when we talk about these cross field issues that I mentioned earlier. Like if we're searching across two different types of science entirely, what is it about those pieces of information that these systems need to understand? What should we be? Is it just the description? Deep mentioned the couple of fields that we're utilizing. Is there something else that we should be introducing into our metadata or pulling from our data to ensure that it's aware of the most important pieces of that particular data? And so the large question is, should we be giving users a visitor map? Welcome, here you go. Or a full guided tour with a headset? Or is it really something in between? So that's all we have today. I think, we have 40 minutes left. While we may not fill the entire time, again, this last portion is really just like here for you to give us feedback. So if you have questions or statements, I'm happy to begin taking notes now, or actually, unfortunately, the email address is not here. Maybe it's way up at the very, very top. I think it is. No, it's not. All right. Well, that was underplanned. Let me get your. I'll drop the email addresses in the chat real quick, or maybe someone else can do that for me. Let's see. So if you guys have questions afterwards, and/or if you think of something later, please feel free to drop an email to us. So I'll do that real quick. I'm going to drop that in chat. So go ahead, Doug. If you have anything you'd like to say now, you're welcome to do so. Otherwise, we can take questions for as long as anybody wants to hang out and ask them.
No, all I have to say is, do we have any questions in the audience? Because I don't see any in the chat as yet. So ask away.
I've got a mic here that I'll run around. Yeah.
Hi, thanks so much for this. I have lots of questions and thoughts. So maybe this is for Deep, but anyone can answer. I'm thinking from the perspective of someone way, way smaller than NASA, that's like managing a much smaller data set, not really even something you would call a collection or a small scale collection. And I'm curious if your idea is that it's appropriate for basically anyone who's providing data to be in the business of constructing these, I guess you'd call them like domain specific language models or chatbots to serve their data. Is that the future of the way anyone and everyone is going to expect to interact with an interface? Or is there a place where we should be thinking more about optimizing our data or metadata structures so that other, more kind of maintained and better developed LLMs can be, hitting and discovering our data sources? Could you speak to that?
Yeah. So I've had a couple of conversations in this space, and I think that what you're mostly describing is the idea of disparate data. Because ultimately we could do this, but then there's another API that does something very similar, and they're doing something, maybe they're using a different model. And there are actually, I don't have it in front of me. I could find it later, but there are some efforts going on in the standards space, IEEE in particular, where we're trying to publish, patterns and ways to present this information. And I think that Stack, for instance, is our currently best option for handling many of these disparate endpoints in existence. It doesn't prevent potential redundancy and kind of additional effort in managing these different tools, and models, for instance. But at least the goal would be that we're doing something very similar in the background, the way we present it. Does that kind of answer your question? Sorry, you're micless.
Sort of.
Yeah, okay.
Mostly. I have a question. So Ryan, you talked about in the early days of NLP, we implemented NLP, was deployed to production. There were issues, so it was pulled out, right? So it was an attempt at taking an emerging technology and put it out into production for the benefit of the users. I think we're in a very similar boat where it's still like it's considered emerging technology. It's not perfect. If you go to any of the big companies, it's all like try our beta experience with, pick your Gemini or AI assistant of choice. So when you talk about the desire to fold emerging technology into the production level systems, like where is that line of like, yes, we need to get it out into the community to start using, or it's not ready enough? So like, what's your approach to deciding when to hit to production or provide a way for users to get at the emerging tech?
Sure. So for those that good question. I think the short answer is it depends. The answer that we're implementing right now is the interface that you saw Deep present is our proposed first step to get something into production, which is really just for us to get feedback on the results, right? So we're not introducing interface adjustments. It's really just like, here is the API in the form of a chat bot. Give us feedback on the data that's coming back based on your search results. And I think the goal there is to improve the backend, right? Improve the ability for our endpoint to provide relevant contextual information to the users. While that's happening, and that's happening automatically, we can utilize Trevor's UX skills and abilities and background to be handling a lot of the feedback and the input that we're getting from users to be designing the interfaces. And the goal that we've discussed is, and largely was kind of A/B testing or opt-in experiences. So for those of you that have used Earth Data Search in the past, if you were to go there now, just in the last couple of months, we've introduced a new, kind of landing page. And that landing page is there to allow us to start doing some of this stuff. So the interface is now just those three pieces of information that we've asked for, and we discussed earlier, rather, the text, the spatial, and the temporal. And we can now reduce the confusion of a user when they enter that interface with some A/B testing, where one of them is NLP focused and one of them isn't, but the interface doesn't change that much. So it's kind of like this multi-pronged approach where like we're trying to get feedback on the underlying, the API, because this is implemented in CMR instead of in Earth Data Search. So we've coupled it with the appropriate backend, which we didn't do in the past, while we get the feedback for the front end. And then once we do get there, I think it's going to be one of two options: an A/B test or an opt-in/out experience based on the feedback that we get.
And so I have inside information that I know that Esdis is big on metrics. So do you have like metrics that you have identified already to where hey, like we've had enough feedback, it's to a point where we're ready to ship this to the big leagues and like actually integrate into interface, or is that still being discussed?
No, so the A/B testing tools that we were utilizing within Esdis were, I'll say, retired and replaced. I think we got access to those new tools last week. So that will be something we're implementing now to start getting that information. And we do have information on that new landing page and how people are using it, which I think will drive a lot of that information as well. So, are they using spatial, temporal, and or the text fields? And, we have to make some assumptions there, but that's kind of the UX aspect of things about what it means when those things are higher or lower numbers.
Cool. Question?
Hi, thanks for your presentation. Very good. I had two questions, one kind of more technical in nature, and then a follow-up more conceptual, I guess. The triplet concept in terms of the thumbs up, thumb down to adjust the space, the vector space. Maybe I missed the detail, but I wasn't clear if that's done in kind of on the fly, or if it's there's some sort of regular update that happens that, or if it needs a full model retrain. If it's a full model retrain, I'm kind of curious how often you're doing that. So just would be curious a little bit more detail on that particular implementation. And then a follow-up to this, there was a comment that was made. I'm not sure if it was one of the spectra of tensions thing, but the personalization of the responses based on a user's thumbs up, thumbs down versus the serving up of more general, more generally available communities. How's that something that you handle? Is it is there a balance that maybe even user controlled, that I see more of my own personal responses, or is it generally people, you're trying to push the more common community responses with that feature?
Go
I
ahead,
can
Deep.
try answering the triplet loss part. Yeah, so the way it's gonna work is so say like we get like responses from the users, feedback from the users, and then I think once a week or once every other week, depending on how many responses we get, we would retrain the model, and then we will push that. We'll do some evaluation testing on that and validate that okay, the new learned model is not actually deteriorating in performance and is actually helping. And that once that is good to go, then we would push it out to production.
Okay, so you're basically using that then as a predictor or a feature in the retraining of the model, what those responses to previous. So is that yeah, so that factors in somehow in your model to what the overall response is in terms of weighting the what's served back to the user.
Yes.
Okay, thanks.
And then, so the second part of your question, if you could clarify for me, it was around that adjustment and how it accommodates the kind of vast user base.
Yeah, I think there was a comment that that giving more personalized responses, could be bad or it could be good depending on what the users need. And so I'm just curious how you're envisioning that's handled, or if that's something that's kind of adjustable, tunable, or like, so what's the right answer? Is it more personalized, more general, or some sort of blend of the two?
Yeah, I mean, I think ultimately that's something that, given a longer discussion, I would probably make Doug answer for me. But I think the safest way to answer that is that we're limited in what we can collect, and I don't want to introduce too many, account level requirements for accessing public data, just for the sake of a better experience. And I think that's again that we saw that sliding scale, or the slider slide, which is like finding a balance between automation and granularity. And I think that where we land on this is really just how much of it we want to be automated and how much we're going to kind of leave on the user and or the interface. But additionally, I think there's interest from NASA, depending on the user, to introduce new products, right? We launched NISAR. We want people to see it and to use it. Some people don't care about it. They're here to do their science and that's it. However, when we have a new product, people, are interested in it. We want to show that to them. And if we're tailoring their entire experience, their algorithm to never surface it, it's also doing us a disservice. And so I don't have a clear answer for you. It's a difficult question.
No, I think that was that. I think you're speaking to the tension that I'm asking about, and that's a good answer. And just from my perspective, today, it seems obviously you do want to be sort of having a very able, generally acceptable model that's out there. But as the technology continues to evolve, this idea of agents and even personalized agents, I think is going to continue to expand and grow. And eventually, this, we're building a world in which, we can define what we need, and it's very well supported. So thank you for your talk.
Appreciate it. Thank you.
So we got Ben with his hand up virtually. What's your question, Ben?
Ryan, Deep, Doug, thank you so much for the compelling presentation. And so I am not an AI expert as much as I might wish I were. I understand from popular conversation that AI LLMs are very compute intensive, lots of energy utilization, and then in theory cost. As we're looking at potentially increased cost constrained futures, do you have any metrics or experience with your work in CMR and Earth Data Search for cost impacts to introducing this capability, or thoughts on whether or not it is a cost efficiency enabler in the future, or risk? Do you have any thoughts there?
Yeah. So for the past few months, like we have been prototyping this into CMR, and we have used two big, I guess, AI models, which is one of them is embedding models in AWS, and then the other one is the LLM that is provided by AWS. Honestly, the embedding models, like it does not cost that much. All the costs are per token, and each token is like about 200,000 to 300,000 characters. So I think what we have seen the most we have used for like LLM testing is like in CMR workload environments, like $10 to $20 at max, right? As of now.
Yeah, so I think
That's not per query, right? That's
No,
like
that's
per
like per month.
thousands and thousands of. That's pretty cheap.
100 million queries a month. Yeah, it's not. It better not be per query.
yeah, I mean, I think the more you look, so I had the table of current and then kind of the future and then really future. I think that the real long-term approach to this allows us to ask for less data. So we don't actually use AI, well, we use it in every request, but essentially just to summarize the user's query, which is very low cost. And then of course we use it when we create the embeddings in the database. And we only need to update that information when there's a change made to a relevant field in the collection itself. And so, you can call it kind of front-loaded expenses and then to some slight ongoing stuff. But I think ideally, the better the discovery, the less cost overall. It won't be something that's like hyper located to a particular position, right? But we had this thing in Earth Data Search ages ago where we had, I'll call it a bug, was a user experience oversight, where there was a button that allowed users to just download entire collections. And that just meant that they were going to go to, S3 or on-prem, wherever it may have been, and grab a whole bunch of data files. And the smarter we can get about returning just one file, or in the form of these more cloud optimized files, a piece of that file, we reduce our egress by just massive amounts. And the amount of HTTP calls are happening again, so we're reducing costs, I think, quite heavily. I think those egress costs are a better cost, or more of a cost savings than the cost increase associated with generating embeddings. And then of course, like the further we go, there's a world where users don't even have to take the data out, right? We can just say, what is the temperature of Lake Michigan? And we can answer that. And that's that far right column. We don't really have a whole lot there to ask. Now, that's of course more compute heavy. And so then you start to weigh out like egress and storage versus AI stuff. And I think this has been alluded to a couple of times throughout ESUB this week so far, but the cost of AI, I think the expectation is that the cost of AI goes up in the foreseeable future because it's being so heavily subsidized right now. But I think there are certain aspects of it that will actually reduce, if we're using AWS, we're not like creating models and the things that are really compute heavy. We're just kind of utilizing smaller pieces of them. My hope is that there are certain pieces of AI that will actually reduce in cost.
I like it. Smarter, not harder, versus like brute forcing searches through the ecosystem. I like that answer. Thanks.
Yeah, and it's all that reduction of steps to science too, right? So not only are you reducing things you have control of, and you can, like Mark said, metrics are always important. Like we can see the numbers we spend, but we don't see the number of hours a scientist spends, right? Once they get a data file. And so that'll be more difficult to measure, but I think that the more we can reduce the workload afterwards using AI, the more science actually gets accomplished. And I think that's where really interesting metrics start to be gathered. And this is like something that many industries struggle with, but we've never actually had the opportunity to even start investigating. But soon the goal, the hope would be that that's now our problem, is like, we're so efficient. How can we make those processes more efficient?
Thanks.
Yep, another question in the room here.
Hold on one second, Brian. Well, so there's a question in chat from a couple of minutes ago. I'll get that one answered real quick. Sorry. So we said in one of your slides, you had the third evolution category that I think was something like data discovery agents. So this is that far right column I was referring to. I was wondering what you think the best source of data is to ground the agents to relevant use cases besides just popularity and tagging and ranking. Really great question. Deep alluded to some of this, just in terms of our ability to measure the quality, right? I think that's what you're talking about with tagging and other methods. this last, I'll say PI, but essentially quarter for those not familiar with the SAFe process. Last quarter, we implemented the ability for CMR to store citation information. There were some ulterior motives to that, but ultimately, one of the things that was recognized, and a lot of this was, give Doug credit for, because this is kind of like his introduction to this AI effort, was let's get these citations in there. Let's read that content, and we can start to make associations for discovery through a multi-level citation, right? So it's like there's this citation. Well, that citation mentions this thing. Cool, what's that? And then kind of step through at some level of depth that you can either define or leave up to some system to determine, but start to use other pieces of data outside of the ones that we're just aware of, and use, I think citations is a really important one. And I think there's an additional challenge there where we can use that citation information, and it's super powerful. However, there's a challenge there too, because our data is cited in many ways, right? Like you'll see it at Poster Hall, at AGU, and at ESIP. And how do we capture those pieces of information as well? And so I think we're in the early days of those things, but that is part of our question, is if there is something that we're unaware of that you think would help ground the truth of what is coming back, we would love to hear it. All right, Mark, you're the one in the back.
Thanks. This is really interesting conversation. So I'm curious, so given the fast pace of, AI models, and trying to keep up with things, we're grappling with, how to pick a path forward that's not going to be obsolete. So I'm curious, for what you've implemented and described here, like how long was that process of deciding to go that route, and what types of things did you consider?
So you're right. Well, it's not moving that fast, right? Yeah, I mean, things are going pretty quickly, and I think that if there was only one thing, which there might only be one thing, that I'll say bureaucracy of government has awarded us, is a little bit of time to step back and take a look at this, right? And so when we initially did this implementation, which was 6 months ago, something like that, 9 months ago, it was a really rudimentary, just vector embeddings of the text. And we started to evaluate different options of ways we could change it, supplement the data, and think about things. And I think what we've come to, in the way that we approach the entire thing from a very early stage, was that system that Deep described. He didn't go into a lot of detail, and I think that's totally fine. But the core piece that we're concerned about is that we can measure every adjustment that we make. And so rather than just chasing whatever's new, we want to make sure that if we're going to do something, it made a meaningful and positive impact on the results that are coming back from our API. And our ability to measure that is something that we have the capability of doing, and we are using every single time. I mentioned that Doug has been really focused on metadata quality, and it's something that from our interfacing perspective has been historically very important, right? Because when you have a facet, if you've used a different term, now 2 facets show up. So we have to have software that manages those synonyms. What's great is that a lot of the discussions that we've had in the past about how our data has to be shaped and what it has to look like and the quality is evolving a little bit. And so we don't have to chase models, but we don't have to chase exact or high quality data in the sense of how we used to think about it before. Now we just need to make sure the information is available to us, and we can continue to retrain and to change models out and measure it. So really the long-winded answer to your question, I think, if I'm answering correctly, is we're just measuring every change that we make rather than continually kind of chasing what's new. Because if we chased everything that's new, I think we'd be lost for sure.
Yeah, another question in the room.
Yeah, I want to say thanks. Again, this has been really great. I want to follow up on that a little bit, because I think there's the chasing after new or improving, and I think being judicious about that makes perfect sense. But I wanted to ask about just maintenance. So just sort of staying where you are as things are changing, and a lot of what we do, the nature of, say, grant-funded development of software is that you get something and you do it, and you want to build something that's going to work for 5 years or 10 years. And how different does it feel now, given that, I don't know, I think that base is maybe shifting a lot, and even not only the technology changing, but even needing to update models? Does it just require a different sort of funding model to ensure that somebody is able to tend to that so that it doesn't become stale without a developer paying attention to it, monthly or whatever, annual basis?
Historically, if we needed something, Doug just wrote us another check from his pocket. Definitely kidding. No, it's a challenge, right? So I don't think there's much difference in the way that, essentially contracts, because I'm a subcontractor. I don't think there's much of a difference in the way that, at least from a funding perspective, that these are funded as much as a grant would, right? It's typically like, because every quarter we go out and we plan with ESDIS, so this is what we're doing, and these are the expectations that ESDIS has from us. And while we have the ability to pivot, like, you've got to be conscious of the fact that you can't just pivot every 2 weeks and produce nothing. And so we typically introduce these things, and going back to the question that Mark asked a few minutes ago, it's all kind of, I'll say, strategic, right? So we do these things in a way to where we're able to introduce new things, knowing there's a slight risk of it becoming obsolete, not being the answer. But this is where Doug and I spend a lot of our time in our discussions, just like, how can you justify 6 people for that effort? And you typically can't, right? So this is like one of the areas where Doug pushes back a lot, justifiably, to say, like, okay, you can have one person, let's focus on that. And until you can prove, that it's meaningful and it's useful, we're not going to continue working on that. And so there's a lot of metrics that have to happen. But as a byproduct of focusing on those metrics and having those discussions, you really start to focus on, the things you're concerned with, basically, which is if it falls out of use. And I don't think we get to that point because we spend so much time attempting to justify it. And ultimately, if we can't justify it, we stop looking at it. But if we do justify it, we go pretty heavy on active development to ensure those things are there. And we have a, I'll say, a core responsibility. Like my goal and my mission here is to ensure that our data is presented and available to users as best as possible. So I think it's less about a policy and a need and more about the desire of all the individuals that work on contracts like this. It's what we want, so we work hard towards it.
I have a follow-up. I think you answered part of your question. So you were asking about like grant funded work, which is quite different from like the Earth Data Search, federal agency, massive contract. To use a parallel of what Ryan said earlier, the early days of Earth, I used to be the product owner for Earth Data Search. I have a lot of, I know all the under the hood stuff. So the decision, Ryan detailed, the NLP was implemented in Earth Data Search, not in CMR. So Earth Data Search had the benefit of that feature, but nobody else did, right? And we talked a lot about what we really wanted for Earth Data Search is we wanted Earth Data Search to be dumb. It's just a skin that sits on top of a very smart CMR. And we got away from that in that particular effort. And so now we're investing in CMR being the brains and trying to make Earth Data Search dumb, right? As a language is a little, we could probably choose better words there, but I think a similar approach might be necessary in the kind of smaller grant funded, to where if all of us in this room have our own individual grants that are being funded and we all go and build our individual tools, at some point that grant money runs out and your effort is done. And they all have different start and end dates. But if we decide, hey, between the 10 of us in this room, maybe there's 3 things that we could all kind of pitch in on together. So when your grant ends, his picks it up and kind of keeps that thing going. I think that would be a model that you could use to make sure that there are continual updates as the industry changes and the tech changes. Again, to make the kind of a shared services smart, and then your grant just takes advantage of this thing being built as a community. I think there was another question right here. Yeah.
I have a question. I come from, and it's similar to the initial question you got in the beginning. I come from a small repository. So for us, really, it's the decision, should we implement something that we can use an LLM for our data? And if, how do you approach it? And how much resource would we need? So essentially, you're a big organization, we are a small organization, but we have the same goal. But how can we as a small organization get there? Maybe we using tools that exist, because we don't want to reinvent the wheel because we probably don't have the funding for it. So do you have any tips of how to approach it from a small repository perspective?
Yeah, for sure. So I'm like very interested in this AI ML space, and I do a lot of projects on my own. There's a really good resource out there called Hugging Face where it's open source. There are a lot of different embedding models. There's a lot of LLMs that you can use for free of cost as like a free tier. And they are as good as like the big models like Claude and ChatGPT. So if you are interested in doing something with LLMs or something in the AI ML space, I would definitely recommend checking out Hugging Face and see what type of models are out there and see what you can use for your specific project.
Totally agree. And I think one thing I want to highlight is, not to like downplay the efforts that go on here, or to downplay anyone else's organizations. As I described, I think in the last question, we have to approach this in a very kind of strategic way. This entire effort that you're looking at right now, with the exception of the fact that like obviously there's data, but the data is open, so anybody can go grab the data. There's only 3 people that work on this project. And so, any given PI, it might be 1 person or 2 people. This last was 2 people. And so we don't have full large teams of people working on this. And I think that oftentimes people look at, NASA as a full organization. There's a lot of different efforts going on, and this team in particular is actually quite small. And so, and we utilized a lot of what Deep just mentioned, these models that are essentially free. And the data is open. You can do quite a bit these days, having spent nothing. Obviously, our time is not free either. I'm acknowledging that, but there are definitely resources out there, and be happy to discuss that later as well. There's a question in chat about the W3C semantic web stack of technologies, whether or not we evaluated them. I'm going to say no. If there was a specific piece of that you thought was relevant, I would be happy to discuss it. But I have not looked at W3C for anything related to this particular effort.
Hey, Ryan, this is Bhaskar here. I'm the one who asked the question. I said at the risk of sounding like a broken record, because I brought this up yesterday as well. The reason I asked that is, the technology has existed for at least a couple of decades now, and there are, not a whole lot, but there are good examples of implementing different technologies from the stack. Using RDF, for instance, or OWL, or SCORS, the simple knowledge organization system. There's a whole bunch of different, depending upon your particular requirements and your level of sophistication, there are different technologies available. And I'm not sure if you've heard something called linked data that was mentioned yesterday. The way I looked at linked data is more a marketable sort of a branding kind of a term for the semantic web, because the semantic web didn't make a whole lot of, it wasn't, the uptake wasn't as great as one would have wanted. So there are a great, in the non sort of academic or non-government, for instance, BBC uses linked data. Music Brains, is another sort of a non-academic or commercial, sort of government sort of implementation. So there are examples out there, and I was just curious. I mean, I work in NASA. I've been at the DAC for over 2 decades now, and I bring this up with ESDIS every now and then. But and the standard answer I always gotten is it's part of their long-term sort of goal. But this particular stack, I don't think has received its fair share of evaluation, and that's one of the reasons I keep bringing it up.
So are you talking about, I mean, because we have systems that use RDF, for instance. I mean, so GCMD that we've referred to uses it.
Mhm.
And the biggest problem, even we just re-implemented the KMS, the keyword management system, and on
Right.
newer technology, new software.
Right.
The typical system and format isn't really the problem. It's more so the volume and the scale that we have to deal with. So I don't know, what, like if you're referring to what CMR being more of like OWL or some other data format itself, the work we're doing now is all in a knowledge graph, right? So we have a process that takes the CMR metadata and puts it into a knowledge graph with those citations. And then, some of the things that Deep didn't go through, like we're using graph embeddings, right? So this is new technology that is utilizing the graph itself, that those standards, we don't have the same capabilities in. So it's less about the data format itself didn't accommodate it, but it's the scale that we have to be able to accommodate, and the tools that do accommodate that scale don't support, those particular
Right.
formats.
Right. Yeah, knowledge graph, for instance, I've tried asking all the best people, and my non computer science background, based final sort of conclusion is a knowledge graph. I mean, is basically an ontology basically provides a schema for a knowledge graph. So, and you don't see that sort of stated as such. And ontologies have been in the works for a long time. The Sweet ontology, for instance, Rob Raskins has been around for one of the longest time periods. And so there are these pieces you see coming out from, based from this technology that people have used, but I haven't seen a sort of a concerted attempts to at least evaluate what is it that it can do to streamline CMR or searches within within CMR itself, for instance. So at least I think it's worth having the discussion.
Or Doug,
So, yep. With respect to semantic web, we have in the past put a considerable amount of effort into leveraging that. I believe even now, as we've migrated our landing pages to Earth Data, those are fully marked up with JSON LD, with a view to them being leveraged by clients using those semantic web technologies. One of the key players in that, it must be like, it's nearly 10 years ago now, was Google and their Google Dataset search engine. So they said, if you put this stuff in there and we get enough tipping point, enough users at tipping point, we will start leveraging that. And there was this magical path that I saw that somebody looking in Google search would type in something very similar to the queries that Deep and Ryan were demonstrating, and Google will do all the heavy lifting and splitting that up. And then because of our landing pages being marked up in that way, we'll be able to point you to the right landing pages. Unfortunately, that never played out. Google didn't live up to their side of the bargain, even though we provided them with enough landing pages to provide that dipping point. They didn't follow through with their implementation. So we have investigated and implemented things like that. The success stories there, though, are we have used OpenSearch in the past for interoperability, which uses a lot of linked data sets, linked data concepts, and also Stack has a lot of the same ideas in it as well. As you probably know, Stack has got a lot of traction. CMR has a Stack API on top of it. We're using it now to do interoperability between NASA, USGS, and INPE, the Brazilian space agency, with their data holding. So some things have been going on. You might not have been aware of them because they've kind of gone under the fold.
Radar, yeah. Right. Okay, no, that's good to know. That's really good to know. I have a feeling, there are these threads, that connecting threads, they haven't been tested out. There are, the technology, the way it evolves, the different terms sort of get used, become, I'm trying to think of the is it the Gartner group, or the group that evaluates technologies? I mean, they have placed semantic web fairly high, at least in the last few years, but it's sort of not up in the areas where you want it to be right now, and that's primarily because at least in earth science you don't see a whole lot, but if you go to biomedical fields, it's incredible. I mean, the amount of work they have done with linked data and ontologies. So, nevertheless, I don't think we probably need to sit down and talk about this a little bit more to see where synergies might lie. And I mentioned this to Douglas yesterday. We've got a semantic technology committee within ESIP, and then you've got the AIML group now. Of course, AIML is kind of is the big bandwagon right now. Everybody's riding on, but there are these sort of almost invisible links that bind the two, and I don't think people have paid a whole lot of attention to that.
Okay, Beth, I said 1 minute now. Take us out.
Okay, 1 minute. I just wanted to mention, since Bhaskar raised it, that there is some good research suggesting that the combination of semantics and other forms of AI and ML and neural nets and that kind of approach are good, right? That you can improve results if you have some semantics. And I would venture to say that even though I think we have tried a little bit of linked data in the ESDIS world, I think we have given semantics itself a little bit of a short shrift, and that there may be some value in paying more attention to the semantic piece of that. And I will stop there. Thank you.
Thanks, Beth.
Yeah.
So we're going to close out now. Thank you very much to Ryan and Deep for the presentation. Give them a round of applause. I'm doing it virtually. I'm sure if we're in the room, Ryan, we won't be able to hear ourselves speak.
Exactly. I'm doing it virtually too. Yay.
Yeah.
Thank you, everybody. Enjoy the rest of your ESIP. See you later.